Hello everyone, my name is Fengchang Bu. Today I'd like to illustrate how to use the software UPCal to calibrate UDEC parameters. I believe that most of you find this video because of these two publications. One is at the International Journal of Rock Mechanics and Mining Sciences, and the other is at the Journal of Rock Mechanics and Geotechnical Engineering. Both publications aim to address the issue of UDEC parameter calibration. I collaborate with my colleagues to develop the open source software UPCal to achieve this goal. Here is the download link. This video will show you how to use the software UPCal to calibrate UDEC parameters. Here is an overview and the graphical user interface of the UPCal. It is a self-contained and easy-to-use executable file. You can input your experimental data to the UPCal, and it gives you the UDEC modeling parameters automatically. Next, I will show you a simple demo. To start, we need to copy the link and download the zip file, and you can extract it. Got the UPCal main document. Open it. You can find the UPCal executable file. Click it. The software will start. The first step is to import the training data. For beginners, I recommend using the system dataset. When you select the option, you can see that the training data file already loaded. Next step is to select the datasheet. What it means, you can see that there are different sheets. Open the second publication at the Journal of Rock Mechanics and Geotechnical Engineering. You can see in the first figure, there are modeling parameters and modeled parameters. Modeling parameters are UDEC parameters. That is what we need to calibrate in UDEC. And modeled parameters is the target parameters corresponding to the experimental data. Normally, after experiments, we can get Young's modulus, Poisson's ratio, unconfined compressive strength, Brazilian tensile strength, cohesion, and internal friction angle. According to previous studies, the Young's modulus of the model is determined by the block Young's modulus and contact normal stiffness. So if we take the example as the Young's modulus to illustrate how to use the UPCal to calibrate the UDEC parameters, including block Young's modulus and contact normal stiffness, we need to select the Young's modulus. You can see that there are three options from 2 millimeters, 3 millimeters to 4 millimeters. What it is? You can open the first publication at the International Journal of Rock Mechanics and Mining Sciences. Open the first figure. You can see that the L is the size of the polygons. That is the block. So if you select the 2 millimeter, it corresponds to the highest resolution. Here we select 2 millimeters. I recommend using this. Next, we need to select the input features as we shown before. What we need to calibrate is block Young's modulus and contact normal stiffness. So we need to select these two variables, E block and Kn. Next, we need to select the target variables, that is, the Young's modulus. Then we import the data and click OK. The next step is to import the experiment data. We just select the parameter group. We don't need to change anything here. To select the experiment data file, you need to establish your own data. you can click the internal file and you find the experimental database. You can see that this is the experimental database we established. It has 99 rock types corresponding to igneous, sedimentary, and metamorphic rocks. So for your experiments, if you just want to calibrate UDEC parameters using your experimental data, you just need to delete those files and only leave your own experimental data. For example, your specimen osmosis is 50, GPA Poisson's ratio is 0.2, UCS 200, BTS 7, MPa cohesion, I set it about 40, friction angle 55. So save it. And then go back to the UPCal software, select the experimental database. You can see that there are different target variables. Here we just calibrate the Young's modulus related parameters. So we select the Young's modulus. Confirm. Click OK. The next step is to train the machine learning model. Here, I recommend using deep neural network. Click the adaptive model training. Click OK. The next step is to do the parameter inversion. You set the input parameter range. So here, for the calibration of block Young's modulus and contact normal stiffness, here are two variables. So here we set the variable as 2, confirm, and you can set the different bonds and step sets. For the recommend bond and size, you can open the first file, first paper, open the table 1. You can see the range and size we recommend. Here we can set 15 to 115. The step set, you can set it as 1. For the second parameter, it is the contact normal stiffness. Because here you can open the system dataset. For the Young's modulus, the value is 1 times 10 to the 13. So we just copy this value to the lower bound and the step size. For the upper bound, it is 101. So we select this value and confirm. The range saved successfully. Click OK. The inversion process automatically started. So we just need to wait several seconds until it finds the optimal combination. Click OK. And then export the results. Select the best parameter combination, Excel, export it. Select the path and the name. For example, here we name it as Young. It's already exported successfully. We can open the Young. You can see that for the block Young's modulus is 56. For the contact normal stiffness is 71 times 10 to the 13. So the next step is to calibrate the block Poisson's ratio and contact stiffness ratio. Let's go back to this figure. You can see that the Poisson's ratio is determined by the block Poisson's ratio and contact stiffness ratio. So here we go back to the UPCal software, clean the data, select the Poisson's ratio, and then according to this figure, we select the block Poisson's ratio and the contact stiffness ratio. That is mu block and the stiffness ratio. For the target variable, it is the Poisson's ratio. Import, click OK, and import experimental data. Before we already defined it, so we just need to change the parameter group as Poisson's ratio, and then select the target variable as Poisson's ratio, confirm. Do the machine learning training again. Set the parameter range. The number of variable is 2, confirm. Go back to the first paper, table 1, and open the UPCal. You can see the block Poisson's ratio from 0.08 to 0.33. The step size, we can set it as 0.01. For the second parameter, the lower bound is 1 and the upper bound is 4. The step size, we can set it as 0.1. Confirm. The inversion process starts automatically, click OK, and export the result. We export it as Poisson's. Successful. We open the Poisson. You can see that the block Poisson's ratio is determined as 0.18 and the contact stiffness ratio is 1.9. The next step is to calibrate contact parameters, including contact cohesion, friction angle, and tensile strength. Go back to the figure. According to previous studies, these 3 contact parameters determine unconfined compressive strength, Brazilian tensile strength, cohesion, and internal friction angle. Therefore, in UPCal, we go back and also select the system data, set it as 2 mm resolution, select the input features as contact cohesion, contact friction angle, and contact tension. For the target variable, it includes UCS, BTS, C, and Phi. Import. Then select the parameter group as 6 parameters, because now we need to calibrate UDEC parameters according to UCS, BTS, C, and Phi. For the experimental data file, we don't need to change. For the select target variables, we need to select it as UCS, BTS, C, and Phi. Confirm. Then, for the adaptive model training, we do it again. We do the inversion again, select the parameter range, the number of variables. This time, is 3. So we change it as 3. Confirm. And go back to the first paper, and you can see the contact properties. We set different bond, different size here. For the contact cohesion, we selected it as 2 to 65. The step size, we can set it as 1. The lower bound of the contact friction angle from 5 to 50, the step size is 1. For the tensile strength is from 6 to 66, the step size, we can set it as 1. Then confirm. It may take some time to complete the inversion process, so just wait for a minute. Now the inversion process is completed. Click OK. Export the result. We name it as stress. Open it. You can see that we got the recommended contact parameters as 59. Contact cohesion for the friction angle is 20. For the tensile strength is 9. So in this way, we got all of the UDEC parameters we need to complete the modeling for intact rocks, but it is just based on the Moore-Coulomb failure criteria. For further improvement, I think you can fine-tune the parameters. It just gives you a range or a roof value of the UDEC parameters. Then you can adjust these parameters according to the response of your UDEC model. Okay, thank you for your listening. If you have any questions, you can contact me by this email. Thank you very much.